We're going to take a look at integration by use substitution or by substitution. Go ahead and make a tab. I'm going to title it use substitution. Alright, so use substitution is the equivalent of the chain rule in derivatives. So the way we use the chain rule in derivatives, use substitution is the same thing but in integration. Alright, so it says the integral of some function in terms of another function is the derivative of that other function dx. Alright, and that's going to make sense in just a second. Alright, number one, rewrite it if it's division. Number two, substitute u in such a way that when you take the derivative, you get part of the function. Okay, that's really important. Substitute u in such a way that when you take the derivative, you get part of the function that's already there. For listening check, color in part of the function only. Just part of the function. Alright, so let's take an example. So example one, let's say you have this function. You want to choose u in such a way when you take the derivative of it, you get a function that's already there. So in this case, I'm going to say if u is 7 minus 3y squared, when I take the derivative, I'm going to get something y, dy. So let's actually do it. So u is 7 minus 3y squared. Take the derivative of that. So step 3, take the derivative du, I forgot to put that in there, and make it look like derivative of g of x dx. So in other words, I want something and the dx in there. In this case, maybe it's dy. I want the 3y and dy. So du with respect to dy, not dx, is equal to negative 6y. Now look, you see I want the function and dy. So I want to multiply both sides by dy, so I'll get du equals negative 6y dy. And you can see it's kind of similar to what I have there. And now I'm going to teach you how to make it exactly the same. If I divide by negative 2, do you see that I'm going to get 3y dy, which is what I'm looking for. So you kind of have to tweak around with it to make it look like what you want it to look like. So number 4, rewrite it with the integral with u and du. So watch what happens. So integral of u, the square root of u actually, because that's what that is, square root of u, and then 3y dy becomes du over negative 2. And I'm going to put the negative 1/2 on the outside. Because remember, the constant is always on the outside of the way. So number 5, integrate. Don't forget the plus c. And it might take you a couple of examples, so don't worry if you don't catch what I just did. It'll take a couple of examples. So that's going to be u to the 1/2 u. So now let's integrate it. Add 1 and divide, right? So negative 1/2 u to the 3 over 2 divided by 3 over 2 plus c. Go ahead and simplify and then return the original u. So on the bottom, 2 times 3 over 2 is just going to give me 3 on the bottom. So I'm going to get negative, then returning the u, 7 minus 3y squared to the power of 3 over 2 over what's left, 3 plus c. Alright, so let's take a look at another example. Again, it might take you a couple, okay? So don't freak out. Alright, this is a cosine one, so let's talk about trigs for a quick second. Remember, it's the opposite, right? So it's the reverse of derivative. So if the derivative of cosine was sine, the integration of sine was cosine. So you're just going backwards. So remember, I remember it this way: sine minus cosine. Derivative is going down, integration is going up. Okay, so integration is going up. It goes sine, cosine, minus sine, minus cosine. So let's substitute u in such a way that you get the other part of the function. So in this case, if I have u equals x squared, if I take the derivative, I'll get 2x, which is what I want to do. So taking the derivative, I'm going to get 2x, and then I'm going to solve for du, because remember, I'm replacing the dx in that function. So solving for du, I'm going to get 2x dx. So notice that's going to whole become du, which is what I want. So now rewrite it with the u's. So I'm going to get cosine of u because u is x squared, and then du is going to replace the whole 2x dx. Now we're going to integrate that. So remember, integrating is going up, so that's going to be sine of u plus the constant. Now return u back into it, so u was x squared, so sine of x squared plus some constant. And that's pretty much, it. That's all there is to doing this by substitution. A few more examples. Alright, so let's say you have this function. Alright, anytime I have division, I'm going to rewrite the division. I'm going to put it on top, basically. So rewrite it. So you're going to get sine 2x, and then the whole bottom to the negative 3, because you brought it up. Alright, so you want u in such a way that when you take the derivative, you get something that's going to get rid of the other part of the function. So let u equal 1 minus cosine 2x. Now take the derivative of that, so you're going to get du equals, and the derivative of negative cosine would be positive sine x. This is a listening check. Color in this chart. Alright, so again, once you get to the bottom, it just goes back around. And then the integration, once you get to the top, it just goes back around. So the derivative would be of negative cosine would be sine. So the derivative is sine 2x times the inside the baby, right, times 2 dx. Rewrite in the integral with u and du, I'm going to get the integral of u to the negative 1/3, and then I need sine 2x dx replaced with du. Now I need to make it look like sine 2x dx. So what do I need to do? I need to get rid of that 2 because that 2 is in the way. So divide both sides by 2. So now I get du over 2 is sine 2x dx, which is what I wanted, sine 2x dx. So now that sine 2x dx gets replaced by du over 2. And I'm going to put the 1/2 on the outside because it's a constant, and now put the du next to it. So now I'm looking good. So now I go ahead and integrate. Negative 3 plus 1 is negative 2 over negative 2. Don't forget the constant outside, which is 1/2, and don't forget the plus c. Alright, so go ahead and replace it and simplify. So it's going to be u was 1 minus cosine 2x, the negative 1/2, and then that's going to be negative 4. So plus c, and then we're going to put it to the bottom. So I'm going to get 4 times 1 minus cosine 2x to the positive 2 power, and negative 1 on the top plus c. This is a listening check. Color in example 4. Color in example 4. So let me do another example. So again, if it's division, rewrite it's not. So now I need to choose u in such a way when I take the derivative, I get x dx. So u is going to be x squared. Take the derivative, so du is 2x dx. Since I only need x dx, I'm going to get rid of that 2. So by dividing everything by 2, I'm going to get du over 2 equals x dx, which is what I'm looking for. Now I'm going to put u, rewrite the integral with the u and the du. So the integral of secant squared u, and then x dx is going to be du over 2, and I put the 1/2 on the outside or automatically. Now integrate that. Remember our function, when we differentiated tan, we get secant squared. So if integration is backwards, the integration of secant squared would give me tan. Okay, we'll take a look at this a little bit in more detail in the next chapter. So differentiate tan to get secant squared, so integrate secant squared to get tan. So it's going to be 1/2 tan u plus some constant. Right, so now replace the original u and simplify if you need to. So it's 1/2 tan, and u is x squared plus c. Alright, let's do one more example, because this one's going to be a little more complicated. You might need to watch it a couple of times, because sometimes they're going to try and trick you. The key is to find u in such a way that when you take the derivative, you get the other thing, right? So again, when you have division or square roots, rewrite them in terms of power. I'm going to let my u equal x plus 4 to the 1/3, because when I think of making my u only equal to x plus 4, when I take the derivative, I get 1. But watch what happens when I make it equal to the whole power. So if I cube both sides right here before I take the derivative, I get u cubed equals x plus 4. If I solve for x, I'm going to get u cubed minus 4 equals x. Okay, I need you to remember that one. Let me take the derivative of this. So that's going to be 3u squared with respect to du equals, and then that's going to be 1 dx. The derivative of x with respect to x is just dx. Alright, you need those two pieces of information. Now I'm going to rewrite those two pieces of information. I'm going to substitute x is equal to u cubed minus 4, and then that part right there is just going to be u, and then dx is equal to 3u squared du. I'm going to simplify this a little bit and make this easier. Take the 3 outside because it's a constant. You're going to get u cubed times u cubed minus 4 du. Go ahead and distribute it. So you're going to get 3 integral u to the 6th power minus 4 u to the 3rd power du. Alright, let's go ahead and integrate that. So I'm going to put the 3 outside because it's outside, put parentheses, and add the power and divide by the same power. So u7 over 7. That one's going to be 4u to the 4th power divided by 4. And then close parentheses plus c. Let's simplify that a little bit, taking it in. That's going to be 3u to the 7th power over 7. Those 4's are going to cancel out, leaving minus 3u to the 4th plus c. Now replace u back in. So my u was x plus 4 to the 1/3 power. So replacing that in, it's going to be x plus 4 to the 7 over 3. because you're going to multiply it by that 7. All right, over 7 minus 3, and again my u is x plus 4 to the 1/3, but it's now also to the power of 4, so 4 over 3 plus c. And just putting the radicals back in because the question was in terms of the radical, it's going to look like this. So you might need to look at this example more than one time. Sometimes you have to get creative in what your u is. Remember, once you take the derivative, you need to get rid of part of the function so that you can do it. Let's practice.